Okay, YouTube, in this video my intent is to cover how to quickly graph linear equations or graphs of lines given two types of equation formats for a linear equation. Starting with this first one here that we're going to refer to as slope-intercept form of a linear equation. This is probably the most common one that you see, but we say any equation is considered to be in slope-intercept form if it's written thusly. And we have y equals mx plus b, where m is our slope or our rise over run. Okay, so we say slope is rise over run, and it tells us how our line will proceed. And then this b value here is our y-intercept, or where our graph hits the y-axis. So we could say that our y-intercept is the point 0, comma b. Recall that if you have a graph and we're talking about its y-intercept, such as this graph right here, we would say that it's the point that it intersects the y-axis at. So it's important to note that at the least I could tell you that the x value there is 0, and the y value here we're claiming to be is b, because if you were to plug in a 0 for x right here, you get y equals b if x is equal to 0, and that point would be on the graph. But essentially, if we know the slope and the y-intercept, then we can quickly construct these graphs here. So when you have equations that are in slope-intercept form, that is, the y is already isolated and in terms of x and it's linear, then we can quickly construct these just by identifying the slope and the y-intercept. So looking at both of these equations here, what we're going to do is start by identifying the slope, and the important thing to note here is with slope, it is always the coefficient or the number that we're multiplying by the x value. So we'd say that this line here would have a slope of -3. I'm also going to write this as -3 over 1. Okay, that would be a slope of -3. And then this line here has a slope of 3/4. So I don't need to write 3/4 over 1. We already have our rise and our run here. And as far as y-intercept is concerned, it's always going to be this constant over here. There's a thing to note here. If we don't have a constant written there, we can go ahead and assume it's equal to 0. But quickly constructing these, we always start by graphing the y-intercept first. So I'll go up 1, 2, 3, 4. This is kind of like our initial amount, what we're starting off with. And then what this -3, the slope represents, is our rate of change, or how it's changing after that initial amount. So in this case, we have a rise of -3 and a run of +1. What that means is we're going to proceed down 3 and then right 1. And we could certainly go ahead and go down another 3 and right 1, and another 3 and right 1, because we know that lines proceed in the same fashion throughout their entire domain. Okay, so we'd say that this line right here would be the equation y equals -3x plus 4, and every point on this line is a solution to that equation. That is, if we were to take it out, like 0, 4 here, and plug it back into the original equation, plugging in 4 for y and 0 for x, we would get a true statement. It is a true value there, set of true values. So this one here, we would say we'd go down to our y-intercept is -2, 0, comma -2, and then we would go 1, 2, 3 up, 1, 2, 3, 4 over. And just note that we only need really two lines, or sorry, not two lines, but 2 points on the line to graph the entire line. So we could say that this is all the solutions to this variable relationship between x and y here. That being said, another format that we see a lot of the time in terms of linear equations is called standard form. And this would be any equation that is written in ax plus by is equal to c form, where you'll notice c does not have a variable. We say c is a constant, so it's like doesn't have a variable, it's just a number. We also say that a and b, these values are not allowed to be 0, because let's imagine if we had a equal to 0, then we'd have like by equals c. And this wouldn't be in this standard form that I'm claiming here, which is ax plus by is c. And likewise for the b, we don't allow b to be 0, because then you'd have ax equals c. But any equation in this form here, what we want to do is we want to go ahead and sketch it. Now, one thing we can do is we can isolate y, and we can rewrite it into slope-intercept form. But what I'd like to share with everybody is this: because when you sketch a line, you only need 2 points on the line, then really what we could do is we could find, say, where it hits the x-axis and the y-axis. We could find what we call its intercepts. And let's say I have a line that I know hits the y-axis here at this point 0, comma, we'll just call it y. And I know it hits the x-axis here at x, comma 0. If I knew these 2 points, then I could say, well, then all the other solutions, because this is a line, have to lie along the line that connects to these 2 points. So the thing that I'm wanting to point out here is this: when you're finding x and y intercepts, at least the y-intercept here, notice this: if you're looking for the y-intercept, then it's guaranteed that the x value of that point must be 0. And if you're looking for the x-intercept, it's guaranteed that at that point the y value equals 0. So what I write here is this: when you graph things out of standard form, we only need 2 points on the line to graph the entire line. I said, well, we shall find the x and y intercepts of the graph, then plot and connect those points if the equation is in standard form. So That being said, in order to find the x and y intercepts, essentially what we're going to do is to solve for the x-intercept, we're going to just substitute y into the equation and solve for x, because we know that if it's an x-intercept, we know the y value is 0. And to solve for the y-intercept, you actually substitute 0 in for x, and you solve for y, because we know that the x value is 0 and a y-intercept. So let's go ahead and take a look at these two equations down here. I'll show you how to quickly piece together your x and y intercepts. But we say when you're given it in standard form, again, we can isolate y again here. We could get y by itself. As a matter of fact, if I do this here, I'm going to go ahead and do that. We say 2x minus 3y is equal to 6. We could subtract 2x from both sides of this equation. And I know that once I do this, I only have negative 3y left on the left side. And I know that the right side, I can't combine my like terms here because they're not like terms. So we'd say dividing everything by negative 3 now. Negative 3. Because we're dividing the entire right side by negative 3, we can actually write this as negative 2 over negative 3, or 2/3, which is positive, and then put the x off on the side. And then we say 6 over negative 3, which is the same thing as negative 6 over positive 3, is a negative 2 in this case. But we're going to see here that when we graph this, we're really graphing the same set of solutions. But the point here is this. If we want to find the x-intercept, what we're going to do is we're going to say, well, then the y value is 0. So if I plug in 0 for y right here, we can actually just do this kind of mentally, but we would get 2x minus 0. Minus 3 times 0 is 0 there, so we get 2x minus 0 is equal to 6. And so if I divide both sides of this by 2, then I would get 3. Okay. Likewise, if we're going to find the y-intercept, we'll just plug in 0 for x. And if we plug in 0 for x here, we'd say 0 for x, it would actually eliminate this term here. We get negative 3y is equal to 6. And so I would divide both sides of this equation to get y by itself, and we would get y that is a value of negative 2. So graphing these, we'd say the y-intercept hit at negative 2, and the x-intercept hits at positive 3, 0. And so we can go ahead and graph these. And we'll go ahead and put the equation on here, so we get 2x minus 3y is 6. What I want everybody to see is that this had a y-intercept of negative 2, which is precisely right here, and a slope of 2/3, so it rises 2, runs 3. So using this method a little bit more quickly this time, I notice I have negative 1/2 x plus 4y equals 4. Not very desirable to get y by itself. If it's in standard, what we'll do is we'll just go ahead and say, well, the x-intercept will plug in 0 for y. And if I plug in 0 for y, this term drops out, and I get left with negative 1/2 x, negative 1/2 x equals 4. And so to get rid of this fraction here, we actually have to multiply by the reciprocal. And the reciprocal of something is just what you get when you turn it over. So I would say take both sides times negative 2, and so I get x is equal to 4 times negative 2 is negative 8. And likewise, if we were to stick in now 0 for our x value, this term would drop out, and we get 4y equals 4, and that is only true if y is equal to 1. Dividing both sides of that by 4, we get 4 divided by 4. So graphing these, we say the y-intercept is 1, the x-intercept is 1, 2, 3, 4, 5, 6, 7, 8, left 8 and up and down none, and we'd say that here is our line. Much easier to do this than to put it back in a standard or slope-intercept form. So that's how you quickly graph lines out of slope-intercept and standard forms.